Hi everyone, today we're going to do a couple of problems with Newton's second law. Alright, we're going to start off with a very basic problem. This is a problem about weight. Okay, so the situation says a object has a mass of 90 kilograms. What is its weight? So to start off, let's start off with Newton's second law. We know that Newton's second law is the summation of all the forces, which is equal to the mass times the acceleration. All right, so we are looking, I'm going to highlight this. We're going to look for the object's weight, and we have the object's mass. So given this, we can, go straight into plugging all of our given information. But just in case, I want to rewrite this net force of F with the actual force. So that would be the force of gravity. Now, you might see me write it as force of gravity, but it can also be written as W for weight, which is equal to mass times the acceleration due to gravity. Now, I'm going to write out the other form that you might see it written as, which is M times G. And this G is the same as A sub G, except instead of having a subscript, you just make it the variable itself. All right, so I'm going to write these equations down right there. Okay, W is equal to M times G, or you could write it like so. All of these are okay. All right, so I'm going to just choose the one that I started off with. It's the one that I am most comfortable with, and it's probably the one that you'll see me use the most. So we know that the mass is 90, and the acceleration due to gravity, that will be technically negative 9.8, but I'm going to use here negative 10, just to make our math a little bit easier. And so we get 90 times negative 10 to get negative 900 newtons. Okay, so that's the object's weight. Now, just so you know, I'm going to do this in blue, that negative, remember, forces are vectors. Okay, so that negative simply means that the force of gravity pulls on the object downwards. All right, cool. Let's do another one. Okay, here we have another problem. This one says a box is being pushed to the right with a force of 20 newtons. The box has a mass of 10 kilograms. Determine the acceleration of the box. All right, so the first thing I'm going to do is I'm going to highlight some relevant pieces of information. We know that there's a force of 20 newtons. Box has a mass of 10 kilograms. And remember, whatever you're looking for, that's also relevant. The unknown is relevant here. So we want to find the acceleration of the box. Okay. What I'm going to do next is I'm going to draw this scenario here. I have a box. I'm going to put the dot inside the box. Okay, so this is my free body diagram. And we know that the box is being pushed to the right. So I'm going to draw a force vector to the right, just like that. All right. And I'm going to label this force vector just as F1. And we know that the force is 20 newtons. Okay. Now, this is not a complete free body diagram, so I'm going to go ahead and complete this free body diagram. We have the weight going down. So F of G is equal to, well, we can figure that out. And then because it's on a surface, we also have the normal force. So I'm going to write that as F of N. All right. Now, we are only looking for the acceleration, but it's going to be good practice to figure out these two values. So after I figure out the acceleration, let's figure out the normal force and the force of gravity. Okay, so in order to solve this problem, remember, we always want to start off with our equation. So the net force is equal to mass times acceleration. And in this case, we are looking for the acceleration of the box. Okay, so now you have to ask yourself, in what direction would the box be accelerating? In the y-axis or in the x-axis? All right, so hopefully you said in the x-axis. So I'm going to write right below where the f variable is, or the force variable, all of the forces acting in this x-axis. And luckily for us, that's only one force. So I'm going to write f of 1 is equal to mass times acceleration. Now, the reason why I went through the process is because, remember, this Greek symbol, sigma, means the summation of, or the total amount of. So we have to look into all of the forces along the x-axis. Okay. Now the next step is to arrange the equation in such a way so that what you are looking for, which is the acceleration here, is the only variable around. So I'm going to divide both sides by the mass. So we get f of 1 divided by m is equal to acceleration. I'm just going to flip that around because I like my unknowns on the left. All right. And now that we solved it in variable form, I'm going to plug in my numbers. Now this might seem a little bit tedious, but trust me when I say this is, for me at least, the simplest way of solving it, because all the way up to here, that's the physics. Like this last part, that's just algebra. All right, so 20 divided by 10, we get 2 meters per second squared. So that will be our final answer for this problem. Okay, so let's figure out the weight. So in order to figure out the weight, we start off with the equation, and we have f of g is m times a. It's already in the format that we want, with the unknown variable being on the left-hand side. And we know that the mass is, what is the mass? 10 kilograms. And we know that the acceleration due to gravity is negative 9.8, but I'm going to write it as negative 10 just to make our math a little bit easier. 10 times negative 10 gives us negative 100 newtons. Now, just so you all know, for at least my class and for the AP1 exam, they won't use negative 9.8, but rather negative 10. And you need to know that in the real life, it's like negative 9.81, depending where you are on Earth. All right, so we have negative 100. Remember that negative simply means that the force is going down. So if there are no other forces in the y direction, okay, and this is it, we got to figure out what f of n is. Okay, so this is pretty cool because now we can use this formula in a different manner. So I'm going to start off with the formula. Okay, now I'm going to make it a little bit more specific. We are only looking in the y-axis. So I'm going to put the y's where they belong. And that's next to any variable that can act as a vector. So force is a vector, so I'm going to put a y there. Acceleration is a vector, so I'm going to put the y there. Mass is not a vector, it's a scalar. Mass doesn't care about direction. So like, it wouldn't make sense to be like, oh, I have a mass of 20 kilograms north, right? That doesn't make any sense. All right. So here, I'm going to add in all of the forces along the y-axis. Okay. So here, I have f of n, which is going to be positive because it's pointing up. And then I have f of g, which will be negative because it's pointing down. And then I have my mass and my acceleration in the y direction. All right, so here's where a little bit of the common sense comes in with the physics. And personally, this is what makes physics really cool. So we know that this object is not accelerating in the vertical direction, right? It's not being lifted off the ground. It's not being pushed into the ground. It's just sliding left and right. So that means that our acceleration, because it's not accelerating the y direction, will be 0. All right, so that leaves us with f of n minus f of g is equal to mass times 0, and that gives us 0 f of n minus f of g. Okay, so now we can arrange the formula for the unknown variable, which is f of n, and f of n is equal to f of g. And we found what f of g was, so it was 100 newtons. All right, yeah, so if I look at that, we know that it's 100 newtons, and we know it's positive because this normal force is pointing upwards. All right, let's do something a little bit more advanced. Okay, so in this moment, we're going to use all our skills and combine it into a little bit more of a complex problem. So we have a box of unknown mass, and it's being pushed to the right with a force of 40 newtons, and it's also being pushed to the left with a force of 50 newtons. The object is said to be accelerating at 10 meters per second to the left. What's the mass? Right, so in order to do this, we're going to start off by drawing a free body diagram. We have a box. That little dot represents the center of mass. Okay, I'm gonna draw my force to the right, and it says that the force to the right, we'll just call this F1. is 40 newtons. I should have highlighted that. It makes it easier for me to see. 40 newtons, and it's also being pushed to the left with 50 newtons. So let's add that in. Okay, we'll call this F2. All right. The object is said to be accelerating at 10 meters per second to the left. So I'm going to highlight that. All right. What is the mass? So that is our unknown. So I'm going to highlight that too, because that's important. All right. Our free body diagram is not complete, so I'll complete it. It's on a surface, so we have a normal force, and all objects have a force of gravity or a weight. Okay, so we need to find the acceleration. It's accelerating we need to find the mass. It's accelerating to the left, and so all of the math that we do here on out should be along the x-axis to start. Okay, so that's our very first clue on where to start. So I'm going to start off with the Newton's second law. F is equal to ma. We know that it's accelerating in the x direction, so I'm going to put the x subscript there as a reminder. Now ask yourself, is this in the x-axis? Okay, is this f of n in the x-axis? No, so I'm not going to write it down. Is this f of 1 in the x-axis? Yes, so I'm going to write it down. Now it's going to the right, so I'm going to have that as positive f of 1. What about this f of g? Is this f of g in the x-axis? No, that's in the y-axis. What about this f2? Is that in the x-axis? Yes, so I'm going to write it down. All right, now this f2 is pointing to the left, and we're going to say that left is negative, and so we have something that looks like this. All right, cool. So we have a problem like this, and all we have to do now is arrange it so that we have our unknown variable as the only unknown variable. Okay, now I'm going to do a cool math trick here because this entire left-hand side, I'm going to put it in parentheses because we want to isolate it from any other mathematical thing. It's kind of like a little mathematical shield, all right? So you'll see why I do this. We're looking for the mass. In order to isolate the mass, I'm going to divide both sides by a sub x. Now what this means here mathematically is technically you're dividing f of 1 by a sub x and f of 2 by a sub x. But because we had this in parentheses, we can just shortcut that and say the entire thing is being divided by a sub x. All right? So a sub x divides from both sides, and we are left with f of 1 minus f of 2 divided by a sub x is equal to m. Okay, this is our only unknown variable. You can rearrange it so that the unknown variable is on the left-hand side. I'm going to go ahead and do that because that is what I like. All right, we know that f of 1 is 40, f of 2 is 50, and a sub x is 10 meters per second to the left. And so remember, anything to the left is negative, so that'll be negative 10. Okay, so we get in our numerator 40 minus 50, so that is negative 10 minus 10, which gives us 1. The object's mass is 1 kilogram. All right, and if we know that the mass is 1 kilogram, we know we can find the weight. 1 times negative 10, the weight is negative 10 newtons. And because there's no other forces on the y-axis, and we saw this in the previous problem, that'll make the normal force 10 newtons. All right, in the next problem, we're going to have two objects. All right, so here we have a box of 10 kilograms is right next to and touching a box of mass 20 kilograms. A force of 30 newtons is pushing a box of 20 kilograms to the right. What is the system's acceleration if the system consists of both boxes? All right, so here we have a couple of interesting things. We have two boxes, so I'm going to have box 1 and box 2. The reason why I can add both boxes in this free body diagram is because we take a look at the system. Okay, and the system is like what is your viewfinder on? What are you focusing on? And in this case, we're focusing on both boxes. Okay, so we're focusing on both boxes here. So we have this, and let's say that this one is going to be the, we'll make this one the 20 kilogram one, and we'll make this the 10 kilogram one. All right. And there is a force of 30 newtons and it's pushing this 20 kilogram box to the right. So I'm going to put this in blue so that it's a little bit easier to see. All right. And we'll call this F1, which is 30 newtons. Okay. So I'm going to do the free body diagram for both objects. We have F of n, we have F of g, and F of g. All right, so this is the technical drawing, okay? But what we can do is we can shortcut this because the system consists of both boxes. We can combine both boxes as one object. I'll be working off of this image here, but I'm going to show you what you can do as a shortcut once you get a little bit more comfy with this. So this would be both boxes combined. So that'll be a total of 30 kilograms. We have our normal force, we have our force of gravity, and there is a force of 30 newtons to the left. So that's the power of looking at objects or multiple objects as a system. There's less drawing, it gets less cluttered, but I want you to work off of multiple objects first before you get too comfy with this idea here of a single object representing multiple objects. Okay? So I'm going to start off with Newton's law, second law, F equals ma. Luckily for us, there's only one force in the x direction. I'm going to put subscript x's because that's where it's accelerating. So we have F of 1 is equal to the mass. All right. Now here, because we're looking at the system as a whole, right? And that's both of the objects. So see what I do here. Just like how I combine both of these objects, okay, like that, into one, I'm going to combine both of the objects into one. I'll represent that with my parentheses. Okay, so this is one object. Well, technically it's two objects, but we made those two objects into one. Oops. Let me go backwards there so that I can write it correctly. So this will be mass 1 plus mass 2. There we go. We don't want to fill in the numbers until the end. All right, so with this, we want to find the acceleration. So we're going to divide both sides by this giant parentheses. Remember, whatever is in parentheses, you can imagine it being just one giant variable. All right, we have this on the numerator, this in the denominator, so they cancel out, leaving us with f of 1 is equal to m1 plus m2 is equal to a sub x. All right, at this point, you can plug in your numbers. So we have 30 to the right divided by 20 plus 10, which is 30 by the way, is equal to a sub x. So we have 30 divided by 30 is equal to a sub x. So that gives us a acceleration of 1 meters per second squared, positive, because it's accelerating to the right. All right, so that's how the system as a whole is accelerating. Now, if we know that the system as a whole is accelerating that way, we have uncovered how to look at a system with multiple objects. Is that cool? All right. I will catch you next time, and we will do a couple more advanced Newton's second law problems. Bye-bye.